Let's add our inventory to the block entity. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Today we are going to add the inventory to our Gem Cleaner block entity the vanilla way, and at the end of the video I will not dive into using my own library. However, in the next video we will come back and we will move our block entity to our using our own library for the inventory. So in this video you will learn how to do the vanilla way. Between the videos I just commented few different constructors for the screen handler, and well, guess what, it's working. So we don't need to overwrite every constructor. The ones that we need is the one that uses block entity and the one that is having the block pose payload. And I did change my library for this constructor. However, I didn't push to Maven yet, so that will happen in few days. Now for adding an inventory into a block entity, as you see, I just implemented inventory. Well, you really don't need to do that. The reason I had done it was that somehow I had to get my hand on the inventory and the handler didn't understand the inventory at all. So I just made the block entity implement the inventory interface so that the handler could actually see the block entity as an inventory. However, in reality, we don't need to do that. Actually, I highly suggest against implementing any interface related to inventories, because as you see, there are lots of overloads that you really don't need to do. We have different classes that are already implementing inventory and we can use them to utilize our own usage. Now, to make an inventory for the block entity, all we need to have is an instance of an inventory class. For example, we can have private static simple inventory, and as you see, it comes from net Minecraft inventory, and we call it inventory, and we can assign it immediately to be a new simple inventory of something. Now let me go one step at a time. We don't need to do this. Okay, now keep in mind we are using 7 here because we have 7 slots, and we are using 7 here. Now what if I want to add a slot somewhere in the graphic user interface? I need to remember to change both of these numbers in 2 places. However, when I come face to face with something like this, a magic number that needs to be placed in multiple places, normally I will prefer to have a public static integer that can be used. So we will have public static final int integer size equals 7, 6 input slots, param1, output slot, obviously. So I can use inventory size here, and in the handler, I can use gem cleaner be dot inventory size. And now at any time, if I want to change this number and I have a new slot in my inventory, or even if I remove a slot from the inventory, I can just change this one single number here and get done with it. I don't need to go into the code and look for it. Now we need to make our inventory simple inventory an in-place instantiation of a class with content. As you saw, the moment I typed it, IntelliSense, and I think it was Copilot, I'm not sure, tried to add lots of things there, but we don't need them. All we need to do is overwrite the mark dirty. And here, instead of calling super, all I will do is call my update method. And remember, we are synced BE. So why do I have problem with this? It says make inventory not static. Of course, it shouldn't be static, and I don't remember why did I make it static, but it needs to be final. Okay, we don't have to overwrite the inventory. Now, if at any point you have an inventory that can change the size, unfortunately you need to instantiate it as a new. At those times, you should remove this final keyword. For example, you may have a chest that accepts upgrades, and based on the number of upgrades, it will add some slots to the inventory. In that case, of course, you can't have a final keyword here because in the game you are changing the inventory size. Of course, it will be a complex situation of handling proper item moving or dropping or things like that. But keep in mind that if you have something like that, the inventory can't be final because you will have to instantiate a new temporary inventory, move the items from the current inventory to the new one, and when it's finalized, then assign it to be the new inventory in the block entity. Okay, now that we have update in the constructor, we don't need to do anything, but if we want to make this inventory sided and available by sides, we need to do things. However, before that, if we want to make the inventory be compatible with any cable mod out there, or actually, we want to make this inventory accept items from another machine or another block entity that sits beside it using the transfer API. We need to override something and give ourselves two new methods. Well, actually, one of them is just a public that sends the simple inventory out, and we call it get inventory. This is just a wrapper that gives us a get method, so return this.inventory. However, for that transfer API, we need another method, and that is public inventory storage. We call it get inventory provider. Now, get inventory provider accepts a direction from NetMinecraft utilmat, and we call it direction. And all we are doing here right now, we say return this.inventory, and not inventory storage here. Be careful, we want a simple inventory. Okay, now that we have this, we have an inventory that can be accepted by the transfer API and move item into it. Beside the simple inventory, we need something else, and we say private final inventory storage equals to inventory storage dot of this dot inventory. Now take note, here we need a direction. When you have an inventory that is not bound to any direction, we can call null there. Okay, and this means that we have an inventory storage that we can access it from any direction. And of course, now I can get that inventory storage, so we say public inventory storage get inventory storage that returns inventory storage. What are the differences between the inventory and inventory storage? Let's say that I have a static block. I will delete it. I'm just using it for demonstration. Here we can say inventory, and putting a dot, we can see the things that we can access to. So from top, of course, we can add any listener to the inventory, or we can add a stack into the inventory. We can check if we can insert the item stack, can player use, and can transfer to, or we can check if it contains any item or a predicate. We can get the count of items. Get held stack will return a defaulted list of item stack. We will look into simple inventory in a few minutes later. Then we can get the max count of stacks, stuff like that, you know. So we are directly working with the slots and item stacks inside the inventory. Now, the inventory storage is a totally different story here. Here, we only can extract or insert into the storage or get a slot from the storage. Remember, we don't get the item stacks in the slot. No, we get the slot or get the slots or the count of slots. So in other words, the inventory itself will let me have access to the item stacks, but the storage is where I can get access to the slots that I need. Now, let's take a look at this simple inventory. As you see, it already implements the inventory, and not only implements the inventory, it's implementing recipe input provider. This is really important. If you want to use your inventory inside any crafting mechanic and get the recipes and read the recipes from the recipe provider and manager, then your inventory needs to implement recipe input provider. And simple inventory is handling both cases. So if you look, recipe input provider just provides a recipe input for the finder. And the inventory, as you saw before, has a size, check for empty, and everything else. Now, guess what? Simple inventory is already handling the listeners and getting the stack, removing the item, or even call for the size is empty, mark dirty, can player use, and clear. And this one is for the recipe provider. So it's already implementing all the methods that you would need to implement yourself. Now, I had seen some people use something else, and that's this. If you go into wiki.fabricmc.net/tutorial:"inventory", you would see that this is the old Fabric wiki, by the way. They are teaching you how to add an inventory to a block, and they have this implementing inventory. This is an interface that extends the inventory, and as you see, it has a defaulted list of item stack. Then of method, of size method, and then it overrides the size is empty, get a stack, and other things, remove a stack and stuff like that. And that would be it. So there is a question. If we compare it to our simple inventory from the Minecraft itself, let's have them side by side. Now, they start with defaulted list item stack. Guess what? The simple inventory has defaulted list item stack. Then they have this of method that returns an instance of the interface with accepting a default list. However, we don't have it here because, well, guess what? We are sending the items here. Instead, if you want to, you can add it for yourself, but I don't see any usage there. And then of size accepts a size. Well, the simple inventory is accepting the size. And then it overrides the size. Let's take a look. Let me open these, and then we will compare the methods one after another. So the size returns getItems.size. However, here we say this.size. So it's easier, isn't it? Because we don't need another method call. Is empty is actually checking that each item stack is not empty. If one of them is empty, then it will return something else. And this is exactly the same code. Mark dirty. Well, guess that this one is not, yeah, here we go, mark dirty. You see that it's totally empty. However, the simple inventory is actually calling the listeners and tell them that, hey, we are changed. So the interface from the wiki page is not complete on the mark dirty. Then we have can player use, or maybe get a stack that we didn't implement here, I think, and remove a stack. So we have few actually things that are written here that the simple inventory is not overwriting, I think. Oh, we have it. Remove a stack. Okay. And then there is the set a stack. Yeah, we have it here. Then the get a stack. Remove a stack. Okay, we have them. Okay. But they are not in the sequence. So let's take a look. We have the get a stack. It returns the get items.get on the slot. And you see that here we are checking a sanity check. And then we say get the held stacks.slot. Again, we are caching the inventory here. So we don't need to do a method call. Then we remove a stack that accepts the slot and the count. It's this guy. So we check the item stack inventories.split stack. Again, here we need to call that method, but the simple inventory is caching it, so it's more optimized, and then the rest is the same. As you see, this implementation of implementing inventory interface is lacking stuff, and basically the simple inventory is handling it. Also, the interface that is inside the wiki is lacking this recipe input provider, and the simple inventory had done it. So honestly, I think if you watch Cup and Joe's video tutorials, even the ones that he's selling, he's always using that interface from the wiki page. Looks like he didn't even update himself using the simple inventory, and he's just repeating one old simple code that he had how long ago, I'm not sure, but he's using it. So don't follow that tutorial. It's old, in my opinion, and you can just use simple inventory. And here, when you are marking the dirty, if you look at this simple inventory again and look at mark dirty, you see that it's calling this listeners thing. So here, of course, we need to call the super and dot mark dirty there to make sure that the listeners are being called and then update ourselves. However, even if you don't do this, well, the update method is calling the listeners. However, here we are doing it specifically for our own listeners on the inventory. So I think calling the super is not a bad thing here in the mark dirty. But if you want to, you can just comment this line and check if the update will work. In my experience, the update alone is working, so you don't need to call the super here. But if you have encountered any problems, yes, you need to call the super. Okay, now that we have everything here, we can move forward and talk about sided inventories. But before that, now that we have the inventory, we need to cover two more things. One is the read NBT and then write NBT. So we need to overwrite read NBT and then overwrite write NBT. As I said, the super call for read NBT is just doing nothing, and the write NBT is doing nothing. So it's irrelevant if you call the super first or do your things and call the super later. I prefer to do everything after the super. super call. And most of the time, you see that people prefer to write the NBT first and then do the read NBT. That makes sense because in old days, people had to do things in order. However, these days we don't need to do that, but it's an old habit, so everyone is doing that. We say var compound or NBT compound or whatever you want to call it equals to new NBT compound. Then we say inventories from netminecraft inventory dot write NBT for this compound that we have. Then we say this dot inventory, but it asks for the stacks, and we have get held stacks. And finally, it asks for the registries. Well, we have registries. And that's it. This will write the inventory to our custom compound. And finally, we will say the original NBT put inventory compound. However, instead of writing that string and hard coding it, I have this class inside my library, Jiraiya GBase constant. If I middle mouse click on it and take a look, we have all of these things that we can use. For example, the inventory is not here. So if you have energy, fluid, or progress, cooldown, any one of these, yeah, has inventory is there, and the inventory itself is not there. So I will use has inventory, and you see that it adds a dot thing, but I have something else in reference dot has inventory key. Now the reference is actually using that has inventory, and it's inside gereference. This one is saying that, hey, this dot mod ID plus that BE has inventory, and honestly, it should be a Boolean. However, in our case, it will work because, well, we have one inventory there and we had written our NBT. Now to read the NBT, we say if the original NBT dot contains, and for the key, we have the reference dot has inventory key, and no, I don't need any one of that. Now that we have the key and we made sure that we have the key, we can say inventories dot read NBT. And here we say NBT get compound. Now that we have the key, we want to tell the system what is the value here. So let's see, it says optional, it returns an optional. So here we say dot get, and it returns an NBT compound. And you see that it's yelling at us that says without is present. Of course, we are checking it there. I'm not sure why it's showing it here, but anyway, then we say this dot inventories that get held stacks, and then registries. This means that we check that, hey, we have this element, then we want to get the compound, and then .get. Now, in previous versions, this contains was using a second argument, and you see that right now it is actually showing us that it is only accepting a string key, and there is one red line showing the error message, okay? But if you are working with older versions, after getting the key, you need this NBT element dot compound type, okay? But as I said, these days we don't need that. And if you want to fix this problem, we can change our code a little bit, and let me just paste it because it's nothing special. So it's get compound, and let's see what's wrong with you now. It says provided optional, so it's optional of NBT compound. Okay, so we get that. Then we can say dot if inventory NBT dot is present, then we can call the get on top. Okay, and this way we don't get any errors. However, here we say can be replaced with a single expression in functional style. Let's do that and see the result. Well, it's calling an action NBT compound goes into inventories.read NBT compound blah blah blah. And it says if it's present, then we get the NBT compound actually, and there we go. So let's call it compound, and this is the final code. Now this code has no warnings, and make sure that it is using this optional thing from the new versions of Minecraft. Actually, before this we didn't have that optional section. Now if you want to, you can be smart and cut this and instead put it there and remove this whole thing and make it one liner. And then of course we can say that, hey, we break this if present into the new line, and well, the lambda can be broken if you want to, but in my case I will not break that one. So if we have the inventory key, then we want to get the compound, and we check if the compound is present, then we get the compound and call the inventories.read NBT on the compound. And this is how you read the NBT in 1.21.5. Now in 1.21.4 and below, you just have this. You just get the compound and directly use it here without the optional thing and get and if present. Okay, so the code would be something like this. It would be the, let me do this, nbt compound, and we call it compound equals to the nbt.get compound. Of course, this will happen inside the if statement below here. So we have the compound, and then we would say inventory.blah like so, directly below that, okay? Without anything else, without any problem, and it would work. So I will just comment it, and that was the original way of handling things for the 1.21.4 and below. However, now that you have the code, you can pause the video and put it anywhere you want. I will remove it because when something has changed in new version, especially things like adding optional, it means that there is no way to go back, okay? And because of that, you don't need to remember the old ways. However, I covered it because some people may not update it to 1.21.5 right now. Now that we read the NBT and we write the NBT, we can move into another class. However, before jumping from the block entity, let me explain why did we add our new compound and put ourselves inside this new compound and then put the compound into the original NBT compound. Because right now we have a hierarchy, you know. We have the original compound and this is our inventory, okay, the blue one. We could directly put this inventory inside the original NBT compound. What we did is that we created a new compound here and we put the inventory into this compound and then put this compound in the original NBT. Why did we do this? Well, right now we only have inventory. That's okay. We could do directly putting inside the original NBT. However, if you have different things like inventory, fluid containers, energy containers, there can be a chance that something has the similar name in them. For example, fluid container may have something like amount, and the energy container will have something called amount. And these two same name variables can potentially cause problems. So when you are dealing with complex things like inventories, fluid containers, energy containers, or any extension of these systems, get into the habit of having your own compound, putting things there, and then, you know, have the compound being added to the original NBT, and this is the way you read it. Now that we read and write and we covered the fact that we need to have our own compound, we are almost finished with the cleaner BE right now. So we can move forward. In the mod block entity class on the registries, because we have added this provider that makes our block entity being able to accept items by item transfer API, we need to have the item transfer API understand the fact that we are able to do that. If you don't know what item transfer API or any transfer API is in the Minecraft, don't worry, we will cover them later. But for time being, all we have to do is say item storage from NetFabric, Fabric API, and you see transfer.version1, and we call sided, means that, hey, we can use the ability of being sided call, and we say register for block entities, and here we say the gem cleaner BE colon get inventory provider, and finally here we say gem cleaner BE as the block entity. Now we have a problem here. It says cannot resolve method that accepts blah blah blah. Oh, take a look. Register for block entities? No, block entity. Thank you. And then gem cleaner get inventory provided, and gem cleaner simple inventory is not convertible to storage of item variant. Yes, because I derped up and inside here I'm returning the simple inventory. However, I need to return an inventory storage, and here we have the inventory storage. So we return the inventory storage and the whole thing is fixed. Okay, keep in mind this line makes the block entity being interactable with other things. If you don't want that, you don't need to have this. And of course, if you don't have this, then you don't need the inventory storage at all. Now, After these, we go back into our screen handler. And here we can have the inventories. Now, we need a simple inventory here. So we call simple inventory and we call it inventory. And we will make it private final because after the constructors, we don't need to do anything. Remember, the main constructor for us is the one that is accepting the block entity because you see that we are calling the other one here. Okay, so let me take this constructor and move it up just to make sure that I'm working with this constructor. Here we say this dot inventory, and I have a typo there, inventory equals to the block entity dot get inventory. Now that we have that, we need to do another thing, and we say this dot inventory dot on open with the player inventory dot player. Now what is this one? Anytime you open a container inside the game that has an inventory, the on open method is being called. Let's take a look at that. You see that it's just a default void inside the inventory class. Now you may ask, did we overwrite it inside the simple inventory? And we can just scroll the whole thing and you will see that we are not writing that on open method here. So basically, this line by itself will do nothing. However, you should get into the habit of calling it. Why? Later in the series, we will learn about mixins. Now, other mod developers can hook into the original Minecraft code and inject their code into the original classes. In other words, the simple inventory may have some functionality inside onOpen because another mod is injecting that functionality, and you, by calling it here, make sure that you are getting benefit from that functional call. When we are doing it, we need to have another override, and that is on close. And here, after calling the super, of course, it's doing nothing, but say, hey, please, this.inventory.onClosed for the player. Okay? Now, you may ask, do we have onOpen? And as you see, we don't have onOpen. And that is why we call the onOpen on the constructor. Here we want to add our slots, but this video is taking long. So in the next video, we will come back and add the real slots into our block entity screen handler. Now, before we go into the screen handler class and dealing with the graphical interface for the inventory, we need to do something else, and we will close the video after that. Whenever you have an inventory inside a block and you're going to break that block, you need to drop the content of the inventory on the ground in the world. To do that, we go into our gem cleaner. Now, I will do the vanilla code, and then after finishing and explaining, I will remove it, and you see that our library is really easy to use after that. Whenever we are breaking a block, we have on state replace method. Now, before calling the super, we need to do things. We say block state new state equals to world.getBlockState at the position. Then we say if not state dot is of the new state dot get block, then we want to do some stuff. Now, before doing anything else, let me explain what's going on. Right now, we get the block state at the position and we check if that state is changed, because this state that is passed through the game inside the method is the old state of the block that we had. We just get the new state, so we want to make sure that something is changed, because if the block is there, then it's not broken. But if we break the block, the state here is related to the old block, and the new state should be something like air. So it shouldn't be the block, okay? So we are comparing the block of the old state with the new state, actually. And if they are different, that is when we make sure that we broke this block, and the content should drop on the floor. So we say if world.getBlockEntity at the position is instance of the gem cleaner BE. No, we don't want any one of that. And let's call it block entity. And now take note, the IntelliSense is giving me some hint. It says, go into the block entity, get the inventory, and read the inventory and stack one after another from the slots in the inventory. And then if it's not empty, block.drop_stack. Use that. However, we have an easier way of doing it using Fabric. We say item scatterer dot spawn, and as you see, the spawn has a method that accepts the position and the inventory. So why not use that? And That's it. We say word pause block entity get inventory. Finally, we say word dot update comparators for the position with this block. Now, I didn't talk about comparators until now, and I will not actually talk about comparators right now. But here I'm telling the system that, hey, the inventory at this block is changed. So if the comparators around this block needs to update themselves, please update those comparators. This line will do that. Finally, we will call the super at the end, and this should be sufficient to drop the content on the floor. However, if you look at gblock, you see that right now I'm not handling the onState replaced because the library was not finished right now. But I have something that I can call here, and in few days when I finish that library class, it will work. And that is drop content on break. And it's actually on the block entity properties. This method call will be used to set a flag. Okay, here you see that it's setting the flag for drop content on break. And if I read that, should drop content on the break and find the usage, you see that it's not finding anything, okay? But as I said, later when I finish my library, we will read it, and this will happen internally in the gblock without the need to do anything else. As you see, I have a commented section in my Jira lib library that is related to this onState replaced, and I'm here checking should I drop content on the break. Then this part of code will change a little bit, but at the end it will handle the same code. So in few days I will just place this code inside there and it will eventually finish the whole thing. So all you have to do is on your block entity properties call the drop contents on break. If you are using my library, chances are that when you are watching this video, that library is already fixed. So you don't need to write this code yourself if you have this line of code. But if you want to go the vanilla way, this is the proper way of doing it. The only thing that is remaining is our screen handler and handle the slots and the inventory here, but I will do it in the next video. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.